So, if you start taking random samples of 100 phone bills at a time, what would the new mean be, and what would the new standard error be? Well, we know from the front page that the mean of the means is the same as the old mean. So the new mean of the means is still 47. It's still going to be 47, the mean of the means, even though we're taking samples of 100 at a time and looking at all those means. But our standard deviation will change. And the formula for that was sigma divided by the square root of n. So we're going to take, so I guess I'll write it like this. Standard deviation of the means is the standard deviation divided by the square root of n. So in this case, it's 9 divided by the square root of 100. 9/10 or 0.9. So the standard error is 0.9. See, the math's very simple, but understanding what we're talking about is kind of tough. Assume the training heart rates of all 20-year-old athletes are normally distributed, with a mean of 135 beats per minute and a standard deviation of 18 beats per minute. And then we start taking samples of size 4 from this population, and we find a mean of each sample. Find the mean and the standard error of these. All right, so the mean of the means is what? Still the same, still 135 BPM. But how about the standard deviation, or the new standard error?
Divided by the square root of 4.
Mm-hmm. Which is 2. So the new standard error is 9. Now the old z-score formula was z equals x minus mu over sigma, but instead this one is going to be z equals x minus mu, stays the same because mu is still mu, but instead of sigma, on the bottom is going to be sigma divided by the square root of n, because it's just putting that formula for standard error in the bottom. All right, the average amount of time that 15 to 19-year-olds spend driving. Want to take a guess per day? I think the average amount of time.
45.
Nope, way lower.
23.
25. Pretty close. 25 minutes. Remember, it's all 15 to 19-year-olds, probably even the ones without driver's licenses. Okay. And that includes the people who live 2 minutes away from their high school and the people who lived in the country. So you randomly select 50 drivers age 15 to 19. What's the probability that the mean time they spend driving each day is between 24.7 and 25.5 minutes? Okay, so here's how you know that this is a central limit problem. See how it says you select 20 drivers or 50 drivers? And the old standard deviation is 1.5 minutes. So we're going to make 2 of these. The first one is going to be for 24.7, so write 24.7 x minus mu, which is 25, over sigma divided by the square root of n. So 1.5 divided by the square root of, what was it, 50? And the other one is going to be 25.5 minus 25 over 1.5 divided by the square root of 50. All right, put both of these into your calculator, get us some z-scores, take out your A16, A17 sheet.
Can you just type this like straight into your calculator?
No, you got to put parentheses on the top and parentheses on the bottom, and then you could type it all at once.
So bottom is in parentheses.
Yes, because otherwise what it's going to do is it's going to divide by 1.5 and then divide again by the square root of 50.
No, I was like, why can't you multiply by the square root of 50? Never mind.
Could you?
Well,
Because it's this divided by that, which could be flipped. That might actually work. Does it work?
Try it.
Try it. Top definitely has to be in parentheses. Correct answer for this is negative 1.41 for this one. And this one is 2.36.
It worked.
Nice. But you did have to have it on the top, just not on the bottom, because it ended up flipping the fraction, which worked anyway.
Yeah, just multiply the square root of 50 on the top.
Okay. So now I've got two z-scores. So now you got to look up on your A16, A17 sheet. Did you guys get 0.9909 minus 0.0793, which gets you 0.91116? Or am I super wrong about that?
0.09.
You wrote it right and said it wrong.
Oh, sorry.
we use different scores.
Different z-scores?
I did the 2.35 instead of 2.36.
Make sure you round. All right. We okay with this? Nathan, where you at?
Good.
Okay. Let's move on to number 5. All right. Average room and board expense per year at a 4-year college. Room and board just means for food and your dorm room. You get a payment plan.
$10,000.
Okay, now this book is,
Oh, food.
7K.
this one is 8 years old. And as of 8 years ago, it was $9,126. All right, you randomly select 9 4-year colleges. What are the probability that the average mean room and board is less than $9,400? All right, notice that they tell you how many, so that means that we're going to be using that x minus mu over sigma divided by the square root of n. So, let's start figuring it out. So we're going to start with x minus mu over sigma divided by the square root of n, which is what? 9126. No, that's the average. So the top should be 9,400 minus 9,126 divided by 1,500 divided by the square root of 9. Which, if you do correctly, should give you a z-score of 0.55. You guys confirm that for me? Okay. All right.